There are different ways a star's life can end, and its fate depends on how massive the star is. There are mainly two types of stars. They can be classified as an average star and a massive star. Stars spend 90% of their lives in their main sequence phase. Sun is considered an average-size yellow dwarf star, and astronomers predict it will remain in its main sequence stage for several billion more years. Main sequence stars are those converting hydrogen into helium via nuclear fusion. As stars move toward the ends of their lives, much of their hydrogen has been converted to helium. Helium sinks to the star's core and raises the star's temperature, causing its outer shell of hot gases to expand. Over its life, the outward pressure of fusion has balanced against the inward pressure of gravity. Once the fusion stops, gravity takes the lead and compresses the star smaller and tighter. Now temperatures increase significantly to the point where hydrogen can fuse to carbon. These large, swelling stars are known as red giants. The shredded outer layers now become a planetary nebula, and the only thing that remains is a dense core. This is called a white dwarf. The white dwarf further cooled to form black dwarfs. Red giant stars reach sizes of 100 million to 1 billion kilometers in diameter. That is 100 to 1,000 times the size of the Sun. If they exist as part of a binary star system, that is two stars revolving around each other, they gather excess matter and their surfaces explode, forming a bright nova. Novas are not as bright as supernovas. But what if the star is way more massive than the Sun? What will happen to it? Red supergiants are similar to red giants. They form when a star runs out of hydrogen fuel in their core, begins collapsing, and then outer shells of hydrogen around the core get hot enough to begin fusion. Fusion continues to the point when only iron is left in the core. Eventually, it will exhaust all its nuclear fuel that runs the star. When that happens, gravity wins. At that point, the core is primarily iron, which takes more energy to fuse than the star has, and the core can no longer sustain outward radiation, pressure, and it begins to collapse. The core is so heavy that it cannot withstand its own gravitational force. The core collapses, which results in the giant explosion of a supernova. That is why only large mass stars explode into a supernova. But super red giants are not the most massive stars. There is another type known as hypergiants, but that is a topic for another video. Thank you for watching.